Okay, so I didn't do my recording for the first few examples, so I'm going to walk us through this student practice, so that way I'll have an example like that in the video. But let's go ahead and walk through it here together. So we're solving rational equations here, and the first thing we want to do is we want to multiply to cancel out the denominator. So Owen, what did you multiply by? Yep, we multiply by 3 to the power 2. And I noticed that as I was coming around, a lot of you guys don't like to write this step, but I would encourage you to. You're going to rewrite the entire problem. Oops. Just like it was in the beginning. But now you're going to put that thing you're multiplying by in the top. I would highly encourage you guys to take the time to write this. Also, don't forget, you want to put these binomials in parentheses. So those were two things that I'm going to recommend you guys do. If you don't have those parentheses, you're going to forget to distribute. Also, if you don't take the time to write this step where you actually put that number on the top of each fraction, it's really hard to see what cancels and what's left. So if you actually write it out, it'll be helpful to you guys. So let's go ahead and move on to the next one. So after we multiply, we're ready to start canceling some stuff off. So Brianna, if I were to simplify this, what would be left? 1, because these cancel each other out. Good. Michelle, if I were to simplify this, what would be left? Good. Just that, right? Because the m squareds go away, but I'm still left with a 3 and an m minus 1. And let's take a look at the last one there. Brittany, what will be left on the end here? Yeah, because the m squareds go away, and I have 3 times 1, which is just 3. And then from there, we get to start solving. So, Niana, what's the first step in solving that? What would you do first to solve that equation? Not sure? Adriana, what would you do first to solve here? Okay. And that's why those parentheses are nice to have, because they kind of serve as a reminder to do that. Miles, what's next to solve for him? Yeah. So what would you do then? So put these together, right? Okay, that's good. Combine your like terms. Sure, we could do that. Jessica, what would you have us do next? Mm-hmm. And then Adrian, what would you have us do last? Okay, so there it is. So that's our first type that we're looking at today. Now, what these have in common, all the ones that we've done so far, is the denominators are monomials. I like to start there. They're usually a little bit easier. We're going to move into a level 2 now, take it up a notch, and we're going to look at problems that have binomials in them, I think. Let me make sure. Thanks. Just kidding. Okay, so no, so I would maybe make a little note here. This is polynomials, right, in denominator. Our first set, if you guys want to go back and label example 1, that's monomials in the denominator. So we kind of saw how to handle it when there's monomials. Now we're going to look at how to handle it when there's polynomials. So if you want to go back and label example 1, that might be a good way to keep those ideas separate in your brain. I'll wait for a second if you guys want to do that. When you have polynomials in the denominator, step 1, is to factor if possible. You might not be able to factor it. We've learned 3 factoring methods. There is the box method, there's the GCF method, and then there's the difference of squares. So we've learned 3 methods for factoring, and it could be either one of those methods. So you just got to take a look at it. So let's start here. You always want to start by looking for a GCF. Do you see anything that I can take out of those 3 terms? So there's no GCF, so I'll skip that. It has 3 terms in it. So what method would I apply there? That's a box method. So let's do the box method on that real quick. In the top left corner, I put the first term. In the bottom right corner, I put the last term. Then I look for 2 numbers that multiply together to give me that, m squared. And that would be m times m. And then I look for 2 things that multiply together to make 30. What would that be? We could do 6 and 5. Now, one of them has to be negative. Which one do you guys want to make negative? Okay, I'm going to make the 6 a negative. Now, I already know it's not going to work, though, so don't put the negative next to the 6. But I want to show you how you know. You're filling your box. Negative 6 times m and 5 times m. You know that you're right if these add up to make the middle number. Negative 6 and positive 5, what does that make? It makes negative 1m, right? I want a positive 1m, which means that the 6 was supposed to be positive, and it's the 5 that's negative. Now they make positive 1. So you got to remember those 2 diagonals have to add up to make the middle. So the bottom trinomial there breaks up into m plus 6 and m minus 5. Now just so you guys know, you know how we have like a lot of guessing and checking to do here a lot of the time? And you could be wrong. Just so you know, usually one of them will already be there. You see that m minus 5? I know that that one had to be m minus 5. Usually they'll make at least one of those things be there so you have less work to do. So you can find it and not have to guess so much. So like, you know it's not going to be 10 and 3 because of that guy, right? So, oh, it's the 5 and 6 because there's a 5 there. That could save you some time. All right. This guy is the same thing. That's good. I don't have to do the work all over again, so I'm just going to factor that one now too. It's m plus 6 and m minus 5. And m minus 5. Once again, put those binomials in parentheses even if they don't. All right, so that's pretty much the new step. I mean, there'll probably be some other new things, but when you have polynomials in the denominator, you need to factor first. It could be GCF, it could be box, or it could be difference of squares. This one was a box method problem. All right. Now what we're going to do is we're going to multiply this by the denominators. So step 2 is what was step 1 last time. Multiply to cancel the denominators. Clean this up a little bit, running out of space. All right, so we're going to multiply to cancel out those denominators. I want to cancel out 2 denominators there. I want to cancel out the m plus 6 and the m plus 5. So I'm going to put m plus 6 and m plus 5, both of them, out here. And what I'm going to do is I'm going to take those and put them all on the top of these fractions here. So it's going to look like this. Uh-huh. It's -5? Thank you. Good catch. Thank you very much. So we're multiplying to cancel. I multiplied by both of those things in the denominator, the m+6 and the m-5. And now we can start canceling stuff out. So for instance, the m+6's here go away, and the m-5's. So I'm just left with 3. What am I left with on the next one? Just 1, because all that goes away. What am I left with on the next one? The m-5 goes away, but that's it. We still have a 1 and an m+6. You don't technically need to put the 1. I'm going to put it, but you don't technically need to. And that looks a lot easier to solve than what we had at first. So from here, there's not much new and surprising. So what did we do? We factored first, then we multiplied to cancel. Okay? So now we're ready to solve. So I've got 3 equals 1 plus 1 times m plus 6. Once again, we do our distribution first. Combine your like terms. 1 plus 6 is 7. And then subtract the 7. And there's my answer. So I think we'll stop there for today. We'll continue this stuff tomorrow.